All right. Well, thanks for the invitation, and I'm sorry I'm not there in person. It's still during the semester, so I couldn't really find time to fly out there. And today, I know that this session is about the AI for science and society, but I thought, because the artificial intelligence in general, in particular, that is represented by the large-scale language models, are used everywhere, including in the domain of science as well as of course overall society. I thought I want to just try to make a bit of an argument, not necessarily scientific argument, but the argument that we all should be able to familiarize ourselves with all those technological, let's say, innovations that go behind building these large scale language models. And then that we should be ready to train these models ourselves whenever it's necessary in order to ensure that there is a competitive edge that we can actually maintain as the AI continues to advance and innovate over time. So now, a lot of people ask me this question, whether they all need to suddenly start training these large scale models, which takes actually a substantial amount of the compute as well as the investment. I'm not trying to say that I'm not trying to make that point, but more like if we are actually present with a situation where we have to train these models, which includes, in fact, just fine tuning these models as well as deploying these fine tuned models in a mass scale, we have to be ready to do so. And then, of course, it's not just about, do we want to do that? Of course, training these models is fun, but there are some very, very realistic reasons why we need to do that. In fact, this whole thing about whether we need to train these models from scratch or we need to be able to train these models ourselves and then serve these models ourselves started when I hosted in 2023, so almost a year and a half ago, the a fireside chat together with JP from SoftBank Ventures Asia and Sam Altman and Greg Broman from OpenAI back in Seoul. And then after the fireside chat, there was a closed door session where we invited about, let's say, 15 to 20 founders or the entrepreneurs who have their own startups. And then one of them was Sung Kim, who's the founder and CEO of Upstage. And then Sung Kim, in fact, asked a question to Sam Altman whether why they need to actually, everyone needs to use OpenAI GPT rather than just training it. And then I also asked Sam as well, just add additional, let's say, comments that after all, OpenAI had only spent about 3 years training these language models. And then OpenAI back then, so a year and a half ago, was still about, let's say, 200 or 300 people only. Why does every other company need to use OpenAI rather than just spending another, let's say, year or two in order to build up their own, let's say, capability? Of course, OpenAI's answer was very straightforward, saying that it's just very, very difficult. Now, I'm not saying that it's not difficult, but you kind of, let's say, guess why they have to say that it was very difficult, because that is their business model and the model for their survival. That is, everyone needs to use their model and not build other similar competitive, let's say, language models to the point that these language models become commodities. And then as soon as they become commodity, then OpenAI actually loses a lot of the competitiveness coming from the fact that they were very early, if not the first one, to successfully commercialize these models. So that's how it started. And then the one thing that I hear a lot from the people is that it's already too late. OpenAI is out there, Google is out there, Amazon is out there. In fact, I guess we're going to hear from the Amazon, the AWS Web Services after my talk. There are so many other companies, but there are a small number of them. They are so much more ahead than we are, or the anybody. When I say we refer to a lot of people. And then they often just give up too early. And then this actually reminds me of some of the things that I have heard about the early days of the personal computers or the PCs. And Bill Gates did not say, confirm that he says so, but in 1981, it's rumored that the Bill Gates said that the 640 kilobytes of the main memory ought to be enough for anybody. And that's the reason why some of you may remember, and I certainly remember, is that the Microsoft DOS only supported 640 kilobytes of the main memory. And then we had to install an extension, let's say software, in order to support the bigger memory. And then that went on for, let's say, a decade and a half or so. And interesting thing is that up until very recently, NVIDIA was a tiny company, especially compared to Intel. It's always been a very small company. What you're seeing on the screen, hopefully the video is actually playing well, is the market cap evolution since 2015 until now of the NVIDIA and Intel. And then don't be surprised, the red curve there on the top is Intel. That's not NVIDIA. In fact, NVIDIA was tiny company. Even in 2015, when everyone who was working on machine learning, including myself, was just using NVIDIA GPUs and then knew that that was the only competitive, let's say, GPUs or the compute resources that are out there and are going to be in the future. And it was only very recently that the NVIDIA took over Intel in terms of the market cap as well as their importance. And then now, of course, their difference is dramatic. What that means is that the being incumbent doesn't necessarily give you the advantage. In fact, being incumbent can be a cumbersome, let's say, burden that you need to carry over. But anyway, I'm going to just pass on because you know what happens to the market caps of the NVIDIA and Intel. In fact, the Pat Gelsinger just resigned from the CEO position, resigned or fired by the board, but either way. So these are the two goals I have. One is to convince you that we can, and that we as in me and you, should train large-scale language models ourselves. And then two is that I want you to give you some of the arguments or the points that you can use to convince your colleagues that you can train LLMs with you. So when you build this kind of AI-driven systems, these are the kind of, let's say, typical stages that you need to go through. You collect the data. So data collection and curation is extremely important. And then once you have collected and curated data, you're going to train or to pre-train these large-scale models. And then during the training is happening in the background, you need to collect and curate the data for the fine-tuning. That is the data that is specific to your downstream tasks. This is a really important part. And then once the pre-training is done, data collection is done, you train this model, you fine-tune this model to serve the actual purpose that you have built these models for. And then you deploy it. And then once it's deployed, it's really important to continuously evaluate and collect feedback. And then, of course, you go back and then you iterate this cycle over and over. So often people want to use the off-the-shelf web or API front-end of a commercial language model because the burden of your own implementation is minimal. All you need to do is deploy a system using these API calls and then just collect the feedback in order to know what is the right way to prompt these systems or to upload some of the collective feedback in order to fine-tune this system to the minimal extent. Now, it's very easy to do it these days. You can use the OpenAI API, very straightforward. Now, sometimes it's desirable for you to be able to customize and deploy the existing models. You're not going to just use the API because API calls actually do come with a lot of, let's say, limitations. You have a very limited degree of freedom in how you can use these models. So sometimes you want to take the model, customize it, and then deploy it yourself. And it turned out that there are companies like Reka or other companies that do provide this kind of private on-prem, let's say, solutions as well. So very easy to go about it. Sometimes you want to actually fine-tune these models because maybe the data that you have collected or that you can collect and curate for fine-tuning is where the true value is. People talk about the language models, training these large-scale models, deployment and whatnot, but these technologies can always be commoditized because these technologies are supposed to be general purpose. This can be used for the many different domains. But if you are in one of the domains, then your expertise as well as the data that you have actually built and can build and collect is in fact the value that you have. So perhaps you don't want to give up on that side and then you want to actually carry that over. In which case you can still stick to this kind of private deployments by the off-the-shelf or the commercial firms such as Cohere there. Now, but I believe in order to do any one of these well enough to the point that you can actually build a system yourself, run experimentation yourself, to the point that you can do let's say, for instance, do the scientific discovery or whatnot downstream, then we must be able to or we must have the capability ourselves to pre-train, fine-tune, and deploy these models ourselves. Now, there are three aspects that I can touch upon briefly. The first is transparency, second is maintainability, and then the third one is compliance. Now, let's talk about the transparency. When it comes to machine learning or data-driven systems, there are many different levels of transparency. Data transparency, model transparency, training transparency, and generation transparency. I'm going to talk about the data and training transparencies today. So one thing that we have seen over the past, let's say, 2 to 4 years is that things are becoming increasingly less transparent. So when GPT-3 was released, together with a tech report of the paper in 2020, it was extremely, extremely well written. I could actually see exactly what was going on there. We knew what kind of data was used to pre-train these models. But then in three years later, in 2023, when GPT-4 tech report was released, there was absolutely no details about it. Now, there are many reasons why they are being very, very opaque about it. There are legal issues and as well as many other issues. However, being opaque is a very bad thing. And it's not only about these closed door models, but it also happens with the open weight models or the so-called open, let's say, AI models. So Meta released a Llama 1 in 2023. And then there in table 1, you could see exactly what is the type of the pre-training data they used. Great. But then in the same year, when they released the Llama 2, what they simply said was it's a new mix of publicly available online data. Who knows what those are? No one has any idea. Now, why it matters is that as we have seen scientifically over the past few years, is that the data, these models are just a different, let's say, noisy transformation of data itself. What that means is that what you added into the data is going to affect what you're going to get out of these models. And then there can be many different, let's say, adversarial attempts at modifying the behaviors of these models. And then without having access to or having transparency into data, you just never know. And then, of course, the type of the data you use will introduce the different types of the biases that we want to avoid or we want to amplify, depending on the situation. But again, without knowing the data or without having this kind of transparency, it's just impossible. Unfortunately, nowadays, most of these pre-trained models that are available out there, we are clueless. There's essentially one or two models for which we have some good idea about what kind of data was used to train them, but otherwise we really don't. And then what that means is that for mission critical scenarios such as in healthcare, security, as well as the other domains, we really have to be careful. What are the things that we can use? And then we have to be ready to train these models ourselves to make sure that we know what we're doing, what we're dealing with. And in fact, the fine tuning is even worse. After all, pre-training these models are great, but pre-training alone is not how people build a language model that are going to go into the actual service. They always fine-tune. And often, they fine-tune this model so that this model's outputs or the results are going to be somewhat aligned better with so-called human values. That's the reason why they call it alignment, which is a pretty much ridiculous, let's say, concept because no one knows what the human value is. And then we never know who are the people these companies went out there to collect the annotations from in order to fine-tune these models. This is the only thing that I could find that is from one of the technical reports from the Anthropic 2022, where they actually do talk about the distributions or the demographic distributions of the annotators that they use in order to collect this fine-tuning data. And then, as you can probably see, these distributions do not reflect, for instance, where we are in Korea. You look at the education level distribution, you look at the ethnicity distribution, you look at the sexual orientation distribution. They're just very different. They are very much of the Bay Area in California. So essentially what Anthropic talked about when they talked about the aligning these language models to human values, or to aligning these language models outcomes to the human values of the Bay Area, or in fact the tech workers in general. And in fact, what is really interesting is that we know that there is no single human value. It's ridiculous that we need to talk about this one, but still, because it turned out that a lot of people don't realize it, people have been actually working on this. So this is one of my favorite papers from last year and then this year. It's from the LSO lab at KAIST, where they actually show that if we go through different countries, even if they speak the exactly same language and whatnot, their, let's say, assessment of whether a speech is a hate speech or not changes. And then this really tells us a lot about what actually is the value that we want to build these models for. And then this is an example from Korea as well. It's a hyperclover X, and then there is a um, this kind of, let's say, ethical, let's say, principles that hyperclover X used in order to train these models. I mean, I'm part of this, the tech report, so I guess, I'm dissing myself. But if you look at the, let's say, item number 9, it says that the hyperclover X shouldn't actually give advices on specialized domains such as medical, legal, and financial advice that could harm users. Now, interesting thing, I work at the Genentech as well. I'm working on the AI for drug discovery quite a lot. That's actually most of the, what I spend most of the time on. I can use HyperClover X because medical advice is exactly what I need in order to use these models for the drug discovery or the healthcare. So, we really have to know about all those things. So transparency really is important because we cannot fix something that we don't know how it's broken. And then unfortunately, we don't even know what's broken these days. So we have to be extremely wary of any outcome produced from this opaque model for any purpose. The second issue is the maintainability or the sustainability. And then there are many issues here because first of all, the world changes, but do we know that these language models change accordingly? Second, if the model is updated, will I be able to continue to use this model? This is a very weird, let's say, legal gray zone there. And then third is that when the model is updated, how will its predictions change? And then it's kind of a ridiculous, again, thing to talk about, but language models do degrade over time. And that is not because of the language model gets worse, but because the world changes. And then the data that is used to train these models are often always lagging behind the time. And then interesting thing, we kind of forgot to care about it. So even nowadays, a lot of people use BERT. BERT is now a tiny language model, but it was considered a moderately large language model, let's say 6, 7 years ago when it was released. And then people are using BERT, but the last time BERT was actually updated was March 2020. That was at the very beginning of the pandemic lockdown and whatnot. And then it's been many, many years. And if you go to Hugging Face, let's say Model Hub, where BERT is indeed hosted, you do see that there were more than 60 million downloads last month. Now, I'm pretty sure most of them are CI/CD loops, that actually downloads it over and over, but that this still tells us that there are so many open source repositories that have an active CI/CD implemented and are running that use BERT that was last trained at the beginning of 2020. And this is a horrifying thing. So this is just looking at the biomedical scientific literature here. And then what you see is that the number of the papers that represent the amount of the new knowledge we actually accumulate in terms of the biomedical domain here is growing so much fast. And in fact, about 10% of all the biomedical papers that we know are from, let's say, past 5 years. And the unfortunate thing is that the BERT has absolutely zero idea about all those new advances or the new knowledge that has been accumulated, some of which actually contradict or they invalidate a lot of the wrong knowledge we had before. So older models will definitely miss out on new knowledge. And then people talk about the retrieval augmented generation as a way to solve this issue. But I have to tell you one thing is that as an NLP researcher and the machine learning researcher, I can tell you that no machine learning model can search for what they don't know. So there has to be some overlap, and if there's something completely different, even the search can fail as well. So in other words, we need to retrain continuously and update accordingly. And if you don't know how to train them, we cannot even just fine-tune these models a little bit. So to do that, we have to have this capability. And then the second issue is really weird. It's a licensing issue. Licenses are actually arbitrary thing that the copyright owners can always put and change and also adjust as well. So, and then the people change. So ESM1 and ESM2 were a very popular, highly used protein language models that were released from Meta in 2019 and 2020. And then they were released with the MIT license. And you can use it for anything. That's fine. Commercial use is fine. But then ESM3 was released earlier this year, and then suddenly they changed the licensing so that this ESM3 could not be used for commercial use, and it could not be used for the drug development or discovery. In fact, the protein language model is like 90% of the reason why people are excited about the protein language model is because of the ESM3. I mean, because of the drug discovery, and then suddenly we cannot use it unless we start paying its evolutionary scale. And then this happens actually over and over. It happened with the AlphaFold 2 as well. Initially, it was Apache License 2.0, which is very permissive. AlphaFold 3, when it was released as an API service only, it was extremely restrictive. So this kind of over-reliance leads to vendor lock-in, and then eventually you realize that you cannot really continue to use these models for free as they are now. And the final point about the maintainability is backward compatibility or lack thereof. When we think about the software pieces or the devices that we buy, every time we buy something or every time we upgrade, we anticipate that everything gets better or stays same, and there are some new features added. But when it comes to machine learning algorithms, that's not true because we don't have 100% accurate algorithms, but the models that are upgraded to have an average accuracy, higher average accuracy. And what that means is that often there are a lot of desirable changes. So incorrectly classified examples are now going to be correctly classified. However, there are a lot of undesirable ones as well. Correctly classified ones become incorrectly classified. Now, it sounds like a pretty dull thing, but if you think about a mission critical scenario such as the cancer diagnostics and whatnot, this can be a devastating, let's say, mistakes that can be made. But of course, we can have some fun the examples of how even the ChatGPT changes. I asked for the list of the capitals of the countries in Far East. ChatGPT 3.5, so I created this almost like this 6 months ago or 7 months ago. It says that, okay, Russia, Moscow, China, Beijing, Japan, Tokyo, on and on, all pretty much good. ChatGPT 4 suddenly makes the list so much longer, but all, looking reasonably well. And then it goes, when you go to ChatGPT 4.0, which was the latest model back then, it actually makes now a shorter list that is different from all of this. Now, according to this particular instance, has ChatGPT been improved over time? It's difficult to tell. Probably some might say no. Now let's go for the more factually, let's say, easy to verify example. What is the fifth largest city in South Korea? ChatGPT 3.5 says that it is Suwon. ChatGPT 4 says that it is Ulsan. ChatGPT 4.0 says that it is Daejeon. So which one do you think is correct? I believe it's actually, the answer is actually Suwon. So it actually became incorrect over time. So I decided to look at another example. What if we do the same question for the North Korea? ChatGPT 3.5, it says Wonsan. ChatGPT 4 says Cheongjin. ChatGPT 4.0 says it's Wonsan. So it was like the Wonsan, Cheongjin, Wonsan. It turned out that the answer is Wonsan. And then somehow there was a regression going from the ChatGPT 3.5 to ChatGPT 4, but there was a desirable, let's say, improvement going from the 4 to 4.0. So it actually tells us a lot about this kind of lack of backward compatibility, which can be critical in a very important, let's say, domains. For instance, one example, just about an hour ago, I asked this question to ChatGPT 4.0. How many times in the modern history of South Korea has emergency martial law been declared? And it actually makes a pretty decent list. But as you can see, it actually stops at bullet point number 5. And as we know, 2 days ago or the day and a half ago, it actually happened again. So what this means is that these models are not, let's say, updated correctly. And then even when it has an ability to search, I think the 4.0 often searches, as you saw from the North Korean version, it says that they search 3 sites. Even then, it just cannot answer these questions perfectly. And then this can be somewhat devastating as well. So this kind of, let's say, backward compatibility or lack thereof is really an issue. And then with the current technology, a lot of people are working on this. It's not easy to address it. In fact, one of my former PhD students who now works at AWS has actually worked on this for some time during 2 to 3 years ago at AWS. And then he suffered a lot as well. And then this can only be, so then what can we do is that we have to have control over training as well as evaluation, because evaluation is the only way in which we can tell which of the checkpoints is the one that I am actually comfortable with and confident in for deploying these models. And then it's really critical because language models aren't going anywhere. And then in fact, I would even say that the 2018 research on LLMs ended. In some sense, my colleagues and I have actually ended all the research there. And it's now at a point where which we're using these LLMs for the actual products. And because it's a product, it's not a research product, but an actual product, long-term sustainability is the top priority. But the current crop of LLMs does not come with any such guarantee, nor the track record of such guarantees, as we have seen just today. So the best way to ensure the sustainability from the product developers is to possess the capability to build or at least vet these LLMs ourselves. So let's see. So there is one last thing that is probably the last part is the sensitivity of the data. Because these large non-parametric models are nothing but noisy versions of the data, we have to be really careful about the data. And then there are two aspects that we need to think about. One is transferring data to a third-party LLM vendor for inference, and then two is using data to train the model and sharing the model. Now I'm going to focus a lot on the one. In fact, a lot of data comes together with the extreme regulation as well as the laws that prevent those data from being transferred freely. And then this is one example from Korea's Geospatial Information Management Act, which says that the basic geographical survey outcomes cannot be transferred abroad. This is one of the reasons why Google Map doesn't really work well in Seoul, and then you have to use Naver Maps, and Naver Maps doesn't really support English well, so it's really difficult, but there is a reason for it. And then this is not a thing that any company or the individual can simply ignore because it is a law there. And it's a similar thing at the EU as well. EU has a general data protection regulation, so-called GDPR. And then in this case, it's actually really, really difficult to comply because any personal data that originated from EU and is transferred outside EU, the protection from the GDPR, in fact, follows. So whatever the data you got from EU, that is a personal data that is under GDPR, you have to actually follow it even if you're not in EU, even if your server is not in EU, even if the data has already been transferred outside the EU as well. And similar thing is that the HIPAA security rule from US. And then HIPAA security rule. So HIPAA rule is actually all about how to make the portability and transfer of the sensitive data easy. However, in order to make it easy, it comes with a lot of the security-related rules and the privacy-related rules. And then according to a security rule, anyone who touches HIPAA, so privacy-sensitive information or the health-sensitive information, they have to implement a technical safeguards. Access control makes sense, audit controls make sense, integrity controls make sense, but then the interesting thing is the fourth one, that is a transmission security. A covered entity that actually handles HIPAA compliant data must implement technical security measures that guard against unauthorized access to PHI, so personal health information that is being transmitted over an electronic network. So we need to actually think about the transmission network as well. So what that means is that we really need to have a full visibility into the data lifecycle that even considers all those APIs solution providers as well. And I believe the AWS, we'll hear about it because AWS actually does provide this kind of, let's say, security compliant solutions as well, as far as I can tell. But how is it really implemented? Is it well implemented? And all those things needs to be considered. And then only way for us to understand what is going on, the whole data lifecycle as well as the language model, is by knowing how to build these systems ourselves. Just like Richard Feynman said, what I cannot create, I do not understand. So I know that I'm actually running out of time, but it turned out that actually training these models is not that difficult. So I actually am an executive director at the Prescient Design, which is part of the Genentech Research and Early Discovery, which is part of Genentech, and this is a part of the Roche, which is the third largest pharmaceuticals in the world. And then we are working a lot on how to design a AI-based platform, what we call lab-in-the-loop platform, in order to design therapeutic antibodies. And then this is a whole thing that we have built, but it turned out that it's really important to have this kind of one large model that is able to look at all those different modalities as well as the different stages of drug discovery in order to improve the success rate of this drug discovery effort, or the de novo drug discovery effort. So I'm not going to talk about the drug discovery in general, but I gave a talk earlier this year at the iClear, one of the premium the machine learning venue, as a keynote on what we have done and how antibody design can progress much better by using AI. But that aside, of course, Roche loved ChatGPT. Everyone wanted to do it. So I wrote a white paper and then convinced everyone at Roche that we need to be able to have an expertise to build these models so that we can actually build a drug discovery specialized models that can really help us design all those new drugs better in the future. So we build a small team. You don't really need a big team. It's about 6, 7 person team that I have built over the past year and a half. And then these people, we have collected all those data and then curated the data that consists mostly of the biomedical data. So we start from some of the models or sometimes from scratch, but we train them to be extremely specialized at the biomedical knowledge. And then it turned out that that's really, really useful. And then doing so, we use all those open source ecosystem because it actually exists there and is getting better and better. Of course, we use PyTorch, we use Lightning, we use Lightning AI's LitLlama as a baseline model using DeepSpeed and so on. And then we use the Hugging Face in order to serve and then fine tune these models. We use VLLM, Fast API, and Streamlit to build a web interface as well as API access. We use a Dexter, OpenSearch, and Weight and Basis on top of the AWS to build the entire pipeline. Data curation, data pre-processing, pre-training, and fine-tuning as well as deployment. And then people can actually automatically upload their data, and people can upload the data. We're going to do automated fine-tuning. And then these are all happening on the AWS using the NVIDIA GPUs. And it turned out it's definitely possible. Now, one of the only thing that matters is that we have to know that the patience is virtue. So Lawrence Van der Martin, who is leading the whole pre-training efforts at the Meta, told me about this. So we decided to just wait long enough. And then it turned out that it actually works pretty well. And then what is really nice about this is that we can start from scratch, or we can start with the Llama models. We can start with any of the pre-trained models off the shelf. We can fine-tune, continue to pre-train with our own domain-specific data, and then we test it on our own problems, we evaluate them, and then we notice that some of these models are working better than GPT-4 or not even after fine-tuning, and then we can just deploy it. And this also doesn't exclude us from using all those openly available commercial API as well. We use the GPT, we use Gemini, and all those different models are being tested and used. But now we know how to evaluate them, and then we can choose which ones we want to use. So these are all the things that have been implemented, and then we're using it. And then these are actually part of our drug discovery or the molecular design pipeline now. So I didn't talk too much about the evaluation, but the evaluation is the most important thing, and then that's the number one thing that needs to be done first. And then what I mean by evaluation is that it has to be something about the problem that you solve. And then this is how you know that the system is getting better, how your system is at what kind of stage your system is at, and then whether you're ready to deploy the system as well. So it's really important. So we work with many of the domain scientists across the organizations, build our own data set that is actually extremely of the high quality and extremely specific to our domain as well. So that actually is about it from me. Sorry if I went over time. If there's any time, I'm happy to answer any questions if there's any. Thank you.
Thank you. Thank you, Professor Cho, for your great presentation. So I think that you guys might be, some of you have questions. So if you have any question, please raise your hand. We deliver the microphone. Yeah.
Thank you for an excellent talk. Hope you can hear me. So my question is really about like the bottleneck you said about how knowledge is kind of set in stone and how it doesn't update as often as we would like. So do you want to speculate like how we should go about like continually learning systems and what do you think must be done to get there?
Yeah, that's actually a great question. So because the amount of the data increases over time and the world is changing, so people want to continue to train it so that the network automatically adapts. And in fact, in machine learning, this idea is called online learning or continual learning, but the more traditionally was online learning. Now, it's really difficult. So when the underlying distribution is stationary, we can write down the loss function and then trying to minimize the loss function that is expected loss over the stationary distribution. But if the distribution changes, then we have to now start thinking about what is the rate at which the distribution changes, and then what is the rate at which we can collect the new data. And then we have to think about what is the rate at which the optimization is happening. because you don't want the optimizations to move too fast, because that's going to in fact lose a lot of the tail information even when the distribution is moving very, very slowly. But because it looks like the distribution is moving faster when you look at the kind of say head or where the probability mass is. Now you don't want the optimization to move too slowly, because then you will not actually adapt to the new distribution fast enough. And furthermore, we have to ensure that the samples are collected in a way that reflects the proportion of the changes. No one knows how to do that. So in reality, people simply retrain these models from scratch, or they're going to retrain these models from an earlier checkpoint. So you don't want to use the final model and then continue from there on, because there's some issue with the optimization being more difficult if you're near the minimum. However, if you think about saving a couple of the checkpoints in the middle, you can in fact start from those intermediate checkpoints and then continue to train it with a newly collected set of data. So yeah, unfortunately, I don't think there is any kind of theoretically valid and empirically well-validated solution to that yet, but quite a lot of people are looking into this kind of so-called unsupervised continuous learning as well as the large-scale online learning these days.
Anyone have more question? Yep, there.
Hey, thank you, Professor Cho. I'm another Joe from Yonsei University in Korea. But anyway, from your talk, I clearly understand we need to construct the large language model by ourselves. However, usually it would take some more effort as well as the computing resources. So I'm wondering if you have any advice on it, coping.
Yeah, that's actually a great point. The amount of the resources you need to train these models, not even like the very, very large models, just at the few billion parameters, few couple of the tens of at the billion parameters already, at the you need. I mean, do you preferably have several tens, if not hundreds, of the 800s or the 800 GPUs, and then that already the budget kind of let's say goes through the roof. So my talk has very much focused on the aspect of the building these systems for making actual products, because once you're actually ready to make these products based on these language models, that means that you are ready to sell these products to make revenue that's going to hopefully create a virtuous cycle that lets you invest into the compute as well. Now, since you said that you're in Yonsei University, do we actually need to train these language models at the university, or does every lab at the university needs to do that? That I'm not entirely sure. As I said earlier, a lot of the research questions that we have about these language models, we already answered it quite some time ago already. Like 2018, 2019, we already did it. And a lot of this individual research were being able to done now. So I think it's actually better for the universities to not actually work on how to work on research on language model training, but rather I think there's actually opportunity for universities as well as this kind of frontier research organizations to look at the issues. And there are so many theoretical as well as the statistical issues associated with the language models. So looking at those issues and then try to come up with a more better principled solutions to them. So for instance, language models are amazing, let's say, associational learners or the correlational learners. What is the right way for us to build a system that is able to extract out the more of a causal relationship that are important in some domains such as healthcare and whatnot? If we have that kind of, let's say, system, is it possible that we can build a smaller model from a large amount of data that is still much more useful because it's going to be causal, it's going to capture causal structure? Perhaps not. But so I almost feel like yes, we want to train it, and then it's going to be a good idea for universities to have this kind of capability and the technical expertise and know-how, but not every lab needs to do that. In fact, not every lab should do this, and then so that we can actually free these kind of research labs from having to train these models, but thinking about something that is beyond. Because this LLM research started 15, 20 years ago, and then back then, not a lot of people were working on this one anyway. So that's my some half baked